Hello, this is Rain from Exam Help Lab. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701 Paper 2, Round 3, October-November 2018. Question number 1. Iron pyrite has a yellow color that makes it look like gold metal. The compound contains the ions Fe2 plus and a sulfur molecule 2 minus. Give the full electronic configuration of Fe2 plus ion. So for the electronic configuration of an ion, you gotta first write the electronic configuration of its neutral atom, meaning that Fe, which has an electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. And that of its Fe2 plus would have 2 electrons less in 4s subshell, meaning it would be 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6. Because electrons only get removed from shell that is of higher energy level, and that's 4s subshell, not 3d. Part 2, calculate the oxidation number of sulfur in sulfur molecule 2 minus ion. Assume that each sulfur atom in the ion has the same oxidation number. So there are 2 sulfur atoms and each has an oxidation state of X. So it would be 2X is equals to -2, which is the combined charge on sulfur molecule. So each sulfur atom has an oxidation state of -1. Part B, describe the metallic bonding in gold. So metallic bonding is a chemical bonding that arises from the attractive force, electrostatic attractive force between the cloud of delocalized electrons and the cluster of positively charged metal ions. So gold has bonding of such kind. So attractive force between cloud of delocalized electrons and positively charged metal ions or gold ions. Part C, iron pyrite is often called fool's gold because of its appearance. Impure samples of iron pyrite often contain a small amount of gold. The gold can be obtained from impure iron pyrite. The impure iron pyrite is roasted in oxygen to produce iron 3 oxide and sulfur dioxide. Gold does not react with oxygen. Part 1, the sulfur dioxide produced during roasting would cause environmental consequences if released into the atmosphere. State and explain one of these environmental consequences. So this sulfur dioxide, which forms when iron pyrite roasts in oxygen, this sulfur dioxide forming will get oxidized to sulfur trioxide by reacting with oxygen, which reacts with again water to form acid rain. This acid rain is not only harmful to marine animals because it increases the pH of river or ocean, but also to limestone buildings. So the environmental consequence is it forms acid rain that damages buildings. Sulfur dioxide turns to sulfur trioxide, which when reacts with water forms acid rain. Part 2, complete the equation to show the roasting of iron pyrite in oxygen. So iron pyrite reacts with oxygen to give iron 3 oxide plus sulfur dioxide. There will be 4 moles of iron pyrite and 2 moles of iron 3 oxide, so 8 moles of sulfur dioxide and 11 moles of oxygen molecules. Part 3, a sample of impure iron pyrite was roasted in oxygen. The composition of the mixture of solid products is shown. Calculate the mass of iron pyrite present in a sample of impure iron pyrite. Assume that all the iron pyrite was converted to iron 3 oxide during the roasting process. So as we were told earlier that gold doesn't react with oxygen, over here that gold does not react with oxygen, we will take moles of iron 3 oxide forming and use mole ratio to find the mass of iron pyrite involved. Moles of iron 3 oxide is equals to mass of iron 3 oxide, that is 33.18 by mR of iron 3 oxide, which is 159.6. This is equals to 0.2079. So the mole ratio of iron pyrite to iron 3 oxide is 2:1. So 0.2079 into 2 would give you the number of moles of iron pyrite that reacted with oxygen. So mass of iron pyrite in the sample is equals to its moles multiplied by the MR of iron pyrite, which is 120, and this is equals to 49.89 grams of iron pyrite. So we have 49.89 grams of iron pyrite present in the sample. Part 4, use your answer to 3 to calculate the percentage by mass of gold in the sample of impure iron pyrite. Assume that gold is the only impurity in the sample of impure iron pyrite. Give your answer to 2 significant figures. So the mass of gold, which we got, is 0.37. We have to take its percentage. The impure iron pyrite contains 49.89 grams of pure iron pyrite plus the gold, which is 0.37. So the total mass of impure iron pyrite is 49.89 plus 0.37 multiplied by 100%. And hence we have the percentage by mass of gold as 0.74%. Question number 2, nitrogen is an inert gas that makes up 78% of the Earth's atmosphere. Explain why nitrogen is inert. So inert is any gas that doesn't react, and nitrogen has this property of being unreactive due to its strong triple bonding that makes it super strong, and it requires a lot of energy to break those bonds. So nitrogen has triple bond that requires a lot of energy to break and react. Part 2, draw a dot and cross diagram of a nitrogen molecule. Show outer electrons only. So 2 nitrogen atoms, each of it will be sharing 3 of its valent electrons. Part B, nitrogen and oxygen react together in the air during lightning strikes to form nitrogen monoxide. Explain why the reaction of nitrogen and oxygen occurs during lightning strikes. So to make nitrogen react with oxygen, we need a lot of external energy, and that's where lightning will help. This lightning will provide energy that is nitrogen's activation energy. Part 2, write 2 equations to suggest how the nitrogen monoxide formed reacts further to create nitric acid, HNO3. So nitrogen monoxide will react with oxygen to form nitrogen dioxide, and nitrogen dioxide will react with water as well as oxygen to form nitric acid, HNO3. We will have half mole of 2NO3 and 2HNO3. Part C, nitrate fertilizers are used to provide nitrogen for plant growth. Uncontrolled use of these can cause a reduction in animal and plant life in natural water supplies. Explain how uncontrolled use of nitrate fertilizers can cause this problem. So these nitrate fertilizers that are added to soil for the growth of a plant, they get washed into a river, and that promotes algal growth that blocks sunlight from reaching marine plants and animals. When bacteria breaks down or it decays dead organisms, that causes drop in oxygen in river, which threatens marine life. So we can write that nitrate fertilizers get washed into river where it promotes algal growth, and this algal growth will block sunlight from reaching marine plants and animals. When bacteria breaks down, decay dead organisms. That causes drop in oxygen. And when there is less concentration of oxygen in the water, the marine life will get very difficult for the marine life to sustain in that environment or surrounding. Probably some salts have compounds such as ammonium nitrate, calcium carbonate, and calcium hydroxide added to them, so just why calcium hydroxide is added to some soils. So calcium hydroxide can increase the pH of water in case water gets too acidic, to increase the pH. Part 2, when calcium hydroxide reacts with compounds containing the ammonium ion, a gas is produced. State the identity of this gas and explain why the reaction occurs. So when ammonium salts react with base like calcium hydroxide, ammonia forms, and the explanation is that calcium displaces ammonia from ammonium salt solution, thus calcium nitrate and ammonia form. So the gas forming is ammonia. An explanation is that calcium displaces ammonia from its ammonium salt solution. Part 3, another fertilizer, calcium ammonium nitrate, is formed when solid calcium carbonate is added to a mixture of aqueous ammonium nitrate and dilute nitric acid. Suggest what would be observed in this reaction. So the first observation would be that solid that is calcium carbonated disappears. Solid disappears. And the second would be effervescent due to reaction between calcium carbonate, which is metal carbonate, and acid. So acid plus metal carbonate would give you carbon dioxide, and that would cause effervescence. Part 4, calcium nitrate decomposes at a higher temperature than calcium ammonium nitrate. Write an equation for the thermodecomposition of calcium nitrate. So calcium nitrate decomposes to calcium oxide plus nitrogen dioxide plus oxygen. There are 2 moles of calcium nitrate, 2 moles of calcium oxide, and 4 moles of nitrogen dioxide. Question number 3. Trihalomethanes are organic molecules in which 3 of the halogen atoms of methane are replaced by halogen atoms. For example, CHCl3. CHCl3 is a colorless liquid with a higher vapor pressure. Explain what is meant by higher vapor pressure. So vapor pressure is gas molecules in equilibrium state, and higher vapor pressure is when there are more gaseous molecules than its liquid molecules. So vapor pressure is gas molecules in equilibrium state, and higher vapor pressure is more gaseous molecules than liquid ones. Part 2, an important reaction of CHCl3 is the manufacture of CHClF2 using the following reversible reaction. Use the data to calculate the enthalpy change of reaction for the formation of CHClF2 as shown in the equation. Okay, so CHCl3 gas plus 2 moles of HF, that is also a gas, gives CHClF2, that's a gas, plus 2 moles of HCl. It's also a gas. This is one part of the cycle that I'm able to build, but right before I do that, I need to see whether I'm given enthalpy change of formation values or of combustion values. Here I'm given enthalpy for formation of 1 mole of CHCl3, which is this one, and it requires carbon, hydrogen, and chlorine in their standard state, so I must write all required elements down here that would help in formation of CHCl3, 2 moles of AHF, 1 mole of CHClF2 and 2 moles of HCl. So carbon in its original state, in its standard state, plus hydrogen gas, plus chlorine gas. Now we have to balance the whole cycle and write all the enthalpies in respect to their number of moles of formation. So we have 1 mole of carbon on all 3 sides, and we have 3 moles of hydrogen atoms on, we are supposed to have 3 moles of hydrogen in all 3 sides, so 3 by 2 here. We are also supposed to have 3 moles of chlorine on all 3 sides, so 3 by 2 again. Here only 1 mole of CHCl3 forms, so we are going to have it labeled as minus 103.2. 2 moles of HF forms out of hydrogen and chlorine in their standard state, so we will multiply 2 into the enthalpy change of formation of 1 mole of HF, which is negative 273.3. 1 mole of CHClF2 forms, which means this will be labeled as negative 482.2, and 2 moles of HCl forms means 2 into the enthalpy change of formation of HCl, which is negative 92.3. Always remember that enthalpy change of formation is the enthalpy change for 1 mole of formation of a compound or a molecule. When there are 2 moles, you have to multiply 2 with that enthalpy change of formation of that molecule. The enthalpy of direct route is going to be equal to the enthalpy of indirect route. The direct route is the formation of CHClF2 and 2 moles of HCl right from the elements in their standard states. So negative 482.2 plus 2 into negative 92.3 is going to be equal to the enthalpy for the indirect route. The indirect route is from these elements in their standard states to first CHCl3 plus 2 moles of HF, and then again to CHClF2 plus 2 moles of HCl, while this is unknown to us. So negative 103.2 plus 2 moles of HCF, which is 273.3, plus x. So when you rearrange your equation, you will have the value for x as negative 17 kilojoules per mole. This is the enthalpy change for this reaction of formation of CHClF2 and 2 moles of HCl. Part 3, the reaction in 2 is carried out using a heterogeneous catalyst. Explain fully the meaning of the terms heterogeneous and catalyst. So a heterogeneous catalyst is all about a catalyst that is in different phase to reactants. So heterogeneous catalyst is in different phase to reactants, and a catalyst is a substance that speeds up a reaction and is not used up in the chemical reaction. Part B, CHClF2 was used as an alternative to chlorofluorocarbons. CHClF2 should no longer be used because it was found to contribute to the enhanced greenhouse effect. Give the meaning of the term enhanced greenhouse effect. Greenhouse effect is caused by human activities that have an impact on climate change. So greenhouse effect is human activities that have an impact on climate change. Better to explain how CHClF2 may contribute to this effect. So CHClF2 will trap heat, and this leads to greater global warming. Part 3 suggests another environmental problem associated with the use of CHClF2. So CHClF2 can also cause ozone depletion. That is, some of its radicals will be reacting with ozone and will be creating those holes in ozone. Part C, CHClF2 is also used to produce the monomer tetrafluoroethene. This monomer can be used to produce polytetrafluoroethene. State the type of polymerization that occurs during the production of tetrafluoroethene. So this is addition polymerization. Draw the repeat unit of tetrafluoroethene. So C2F4 is C2C double bond and F2F on each carbon atom. This will polymerize to tetrafluoroethene, where this double bond breaks and two new single bonds will form on either sides. Part 3 suggests why tetrafluoroethene is used as a coating for cooking pans. So this is because of its unreactivity. Because you wouldn't want your pan to be covered with something that's easy to burn. Part 4, waste disposal can cause litter problems. State 2 other difficulties associated with the disposal of PTFE, that is tetrafluoroethene, that is the polymer formed out of addition polymerization. So PTFE also releases harmful gases when it is burned. And the second disadvantage could be that it is non-biodegradable. Question before the structure of glycolic acid is shown. Complete the table to show what you would observe when an aqueous solution of glycolic acid is added separately to each of the reagents. If a reaction occurs, state the functional group of glycolic acid that is responsible for the reaction. Okay, so Na2CO3, that is sodium carbonate, is a metal carbonate that reacts with acids. So this glycolic acid has a functional group COOH with which this Na2CO3 will react. So we will have a reaction occurring over here. The observation with glycolic acid would be an effervescence will be seen, because when acid group reacts with a metal carbonate, carbon dioxide is evolved, and the functional group responsible for this reaction of glycolic acid is COOH group. Now 2,4-DNPH reacts with carbonyl compounds only, so no visible reaction, since we don't have any carbonyl compound in the glycolic acid structure. Acidified chromate ion is an oxidizing agent that reacts with primary, secondary alcohol, and aldehydes. Here, the functional group that's responsible for a reaction is this alcohol group, and the observation is going to be orange to green. So this solution will turn to green from orange. Part B, 2 reaction sequences to make glycolic acid are shown. Draw the structure of X. Here in sequence A, HCHO, which is ethanol, when an aldehyde reacts with HCN and NaCN, a nucleophilic addition reaction takes place, meaning that this O will expand into OH and a nitrile ion will be attached to this carbon atom. Now the structure of X would be HCH. This O will now have H attached to it from HCN and a nitrile ion from NaCN. So this is going to be the structure of X. Part 2, name the reagent for reaction 2. So reaction 2 is turning this nitrile group to carboxylic acid group, and that requires dilute HCl. So we can write dilute hydrochloric acid. Part 3, name the mechanism of reaction 3. So reaction 3 is a free radical substitution reaction because one hydrogen from here is getting replaced by an atom of halogen molecule, that is bromine. So this is free radical substitution reaction. Part 4 suggests the essential condition for reaction 3. So for free radical substitution reaction, we always require UV light. Part 5 reaction 4 occurs by an SN2 mechanism. Complete the diagram for the mechanism for reaction 4. So SN2, because this is a primary halogenoalkane which has no stable intermediate. Now this bond will be breaking heterolytically. Carbon will have a partial positive charge and bromine will have a partial negative charge. There will be an arrowhead towards Br. This bond will be breaking heterolytically, and at the same time OH with a lone pair of electrons will be attracted towards partial positively charged carbon atom. Part C, glycolic acid can also be made by reacting glyoxylic acid with NaBH4. Part 1 state the role of NaBH4 in this reaction. So this has an aldehyde group. This over here is an aldehyde group, while this over here is a carboxylic acid group, and this goes under reaction with NaBH4. This aldehyde group reduces to a primary alcohol, and this will stay the same, meaning NaBH4 is acting as a reducing agent. It reduces aldehyde group back to primary alcohol group. Part 2, write an equation for this reaction using molecular formula. So glyoxylic group has a molecular formula of C2H2O3. It reacts with NaBH4, which we will be representing with the use of this H. This gives glycolic acid, which has a molecular formula of C2H4O3. There will be 2 moles of NaBH4 we will be using in this reaction. Part D, when glycolic acid is heated in the presence of a sulfuric acid catalyst, a new compound Y is formed. The equation for the reaction is given. The infrared spectrum of Y is shown. State how this spectrum differs from an infrared spectrum of glycolic acid. Explain your answer with particular reference to the peaks within the range 1500 to 4000 per centimeter. So glycolic acid is CH2OH and COOH. Now this would have a strong and broad peak at 2500 to 3000 per centimeter due to this functional group, and also a strong peak at 3200 to 3650 per centimeter due to this primary alcohol. So glycolic acid will have a strong peak due to carboxylic acid group at 2500 to 3000 per centimeters, and again a strong peak due to alcohol group at 3200 to 3650 per centimeters. Part 2 suggests a structure for Y. So if you look at the infrared spectrum of Y, there is no strong peak here at 3200 to 3650 per centimeter, which means that Y has lost this primary alcohol group. Now glycolic acid has a primary alcohol group and a carboxylic acid group that must have reacted among themselves in the presence of H2SO4, as it is stated right over here that glycolic acid is heated in the presence of a sulfuric acid, and glycolic acid has both the functional groups and we have the catalyst sulfuric acid also. They must be reacting among themselves in the presence of that catalyst. Now, a molecule that contains both COOH group, that is carboxylic acid group, and a hydroxyl group, that is OH group, this has the possibility of forming a cyclic ester. That is, when a carboxylic acid reacts with an alcohol, an ester linkage forms. And as stated in the beginning of the part of this questions, we have 2 moles of glycolic acid, means 2 moles of this structure where we have COOH group and OH group. So 1 mole of glycolic acid has this structure, and the other mole of glycolic acid has this structure. Now hydrogen from this hydroxyl group and OH from this carboxylic acid group will be reacting, and this OH and the hydrogen from this hydroxyl group will be reacting and will be releasing H2O molecules. Now these two will be connected. Now these 2 moles of glycolic acid will be connecting with release of water molecules. Now we have CH2 and then CO Now this carbon atom will be attaching itself to this oxygen atom. So oxygen, and then carbon, and then this carbon atom is attached to this double bonded CO, and then this carbon atom will now attach to this oxygen atom. So this O and this O is attached to this carbon atom. Now you need to give this structure a shape of a cyclic structure. So it will be C2O double bond, then ester linkage, and then C at carbon atom again, where we'll again have an ester linkage. So this is the structure for Y. So that was the end of the paper. Thank you for watching.